So here I've brought up the Splay tree code in an editor called Emacs, and this is my personal editor of choice. It's doing syntax highlighting and indenting very much like the Udacity online IDE would do for you. But here what I'm doing is running this on my local PC here. And so what we can see is we have a Splay tree class. It supports an insert method, a remove method. This takes a key out of the tree, a couple of other operations. So insert, remove, and lookup are the basic operations supported by any binary search tree, but many implementations support additional operations. So find is the lookup operation for this tree. And then there's a Splay operation, and what Splay does is it moves a particular key up to the root of the binary search tree, up to the root of the Splay tree. This serves as both the balancing operation for the Splay tree and also the lookup. So the Splay routine involves a couple screenfuls of code, but it's still fairly simple. And now let's go look quickly at the test suite for this. So the author of this open source Splay tree wrote a test suite. And this test suite, you can see, imports the Python module unit test. And what unit test does is basically provides a little bit of infrastructure for running unit tests. And so what it's going to do is automatically call these different functions which are defined for an object inherited from the test case framework. And you can see here that what we do is, for example, we have a setup routine that initializes a list of keys. We make ourselves a new Splay tree and insert those 10 elements into the tree. We have a test insert function which loops over all of the elements of the tree and asserts that they're found. We have a remove test function, which is going to be called last in our test suite. The functions beginning with the string test are called in alphabetical order, and this happens to be the last one. This is going to remove all of the keys from the tree. And finally, we have a function which is going to insert a large number of elements into the tree. It's going to insert 40,000 elements into the tree. It's going to make sure that they get staggered by a gap of 307. This is basically going to end up stress testing our Splay tree a little bit. Finally, we have a routine that tests whether the tree correctly knows that it's empty. Okay, so this is our sort of minimal unit test. And what we can do is we can run this. And this is going to take just a couple seconds to run. Okay, so all those tests took about 1.6 seconds to run. And what I'm going to do now is run the same tests under a code coverage framework. So what I'm doing here is erasing the code coverage state, which has been previously stored in this directory, running the Splay test under the coverage framework, which is basically going to run an instrumented version of the code. And we'll talk about how this all works a little bit later and what it means. And then we're going to generate some HTML. So what you can see is it ran quite a bit slower this time because instrumenting the code to measure coverage adds a lot of instructions to the code, and this takes extra time. Okay, now we're going to look at the output. Here we are looking at the output of the code coverage tool. And what it's telling us is that when we ran the Splay tree on its own unit tests, out of the 98 statements in the file, 89 of them got run, 9 of them failed to run, and we'll talk about this excluded business later. So the lines which didn't get run are marked in red. And so this first one we're going to skip over for now, and let's look at the second example. So the second line that didn't get run is in the Splay tree's insert function. What we can see is that the test suite failed to test the case where we inserted an element into the tree and it was already there. And if we look at this, it looks fairly harmless. We're just erroring out. But we're not going to worry about this one right now. So let's move on a little bit. So here we get something a little bit more interesting. So here we're in the Splay tree's remove function. So we're going to remove an element from the tree. And so what you can see is that the first thing this function does is splays the tree based on the key to be removed. And so this is intended to draw that key up to the root node of the tree. If the root node of the tree does not have the key that we're looking for, then we're going to raise an exception saying that this key wasn't found. But the thing to notice here is that this wasn't tested. Now, if we look below here and more into the body of the delete function, we can see there's a pretty significant chunk of code that wasn't tested. So we'll probably want to go back and revisit this. And so let's take a step back and think about what the coverage tool is telling us here. It's basically showing us what we didn't think to test with the unit tests that we wrote so far. So what we're going to do is go ahead and fix the unit tests a little bit in order to test this case, in order to test the case of removing an element from the tree where it's not there. So let's go ahead and go do that.